Hi everyone. So I'm Craig Scott Angell. I currently work as a lead software test engineer. I work in the tech startup industry in Edinburgh. My colleague David Brownhill worked with me at a company called Skyscanner, where we got into security testing, which seemed a natural progression from quality software from a functional point of view to include the security side of things. We're going to go through a couple of things that we've been doing since then, with two examples of how we've automated security. So I've worked for a long time in software testing, notably the finance and defense sector. Very often companies I've worked for have been reactive. We've tried to switch that to be more proactive in how we're testing for these things. And also with a move to Agile in a lot of companies now, bolting on security testing end of projects does not work. So you need something with faster feedback. Manual testing isn't always feasible during the development cycle. We typically work in 1 week sprints. We've worked in 2 week sprints in the past. To get manual security testing in each of those for everything you're developing just doesn't work. So automating things is the natural progression. So there's a couple of things we've done. The first thing, which is probably more important than the technical aspect, is to build a security-aware and security-conscious culture. I think the shift in behavior and thinking is probably the first step. Otherwise, you don't get buy-in, and these projects get left on the side. We include everyone, so as well as the engineers, we talk to people higher up in the company, we talk to other departments, we try and get sort of people to be aware of what security means, what the risks are in the industry, and get buy-in that way. And then we build it into the methodology of how we work. And the key is to automate, iterate, and automate some more, and have that just running continuously to give us feedback. So the educational side, so usually it starts off with knowledge sharing sessions, talks. These build up to workshops where people can attend, try things out, and then we usually try and roll out some sort of online training. People don't always like to do stuff that's forced upon them, so it gives them a chance to do stuff in their own time. But one key thing that we found works is in each engineering team, if we can train a security champion that pushes this stuff into the team, into the methodology, a point of contact for the company, that we see better uptake in automating of security and following secure coding practices. So we leverage different tools to do this, static analysis, dynamic analysis, security tools. What we do is we treat everything that comes back from these just like any other functional defect that we find. We categorize things by severity, high, mediums, low, and take them into each sprint based on highs first, medium second, and just work our way through that list and start fixing things up. So there's a couple of things that we've used in the past and looked at, done various trials with. There's a framework called BDD-Security, Mitten with Burp Suite integration, Gauntlt, and we use other dynamic security scanning tools. Arachne Scan is open source, and we've also used paid services as well. Often in the tech sort of startup industry, we try and go open source, but paid services are the experts. Sometimes that's the right thing to do as well. So one of my favorite of the framework is BDD-Security. We used that heavily when we were at Skyscanner. This allowed us to quickly build an automation framework as it comes with a lot of scenarios predefined. It uses BDD Gherkin syntax, given when then. It's a high-level scenario description, so people outside the technical areas can also understand what we're testing. So it comes with a range of tools. OWASP app is probably the main one it uses to drive for a lot of the testing, but it also uses Selenium driver for the web interface, extendable to Nessus Security Scanner. The one we used was version 1, used JBehave and Apache Ant. The current version I'm trying to implement now in my current company is version 2 using Cucumber and Gradle. The good thing with this is, as well as the non-functional security aspects, we get to test the functional side. We can test captures, limiting login attempts, and various other things that we can drive with the Selenium driver in the web front end. We find this is beneficial because very often those have to be in separate suites, but we can have everything security focused together. We also managed to integrate a REST API for testing, a REST client, and we can test our API the same manner with these scenarios as we can with anything else. So as I said, many stories are predefined. I'm not going to read off every one of them. There's a lot more of these. You can go and have a look online yourself. But there's quite a lot out of the box. It also comes with a sample application just to try things out before you even start implementing anything. So scenarios are set into stories. We have feature files, which has a narrative. There's essentially a collection of like-minded scenarios to test an area of an application, and it follows a given when then. So we've got an example here for open ports. Given some prerequisite, when some action happens, then some assertion. They're pretty straightforward and very easy to write, and these link then in the back end to the automation scripts that drive these tests. There's another example here with 2 scenarios in it on cross-origin resource sharing. This was one actually with an intern that we fed back into the open source framework. Again, on the education side, we got an intern involved, got education. He said he didn't do much security at university in his software course, so it was another progression to try and get stuff into the industry. So here's an example of how we did that from a pipeline point of view. So our source code is in Git repository. We use a continuous integration server. We use TeamCity at the time, and we're using AWS as a service as well. Hopefully you can see that clearly there. So TeamCity via Ansible was pushing a package up to an S3 bucket. We have an instance which we only switch on when we need it to run these tests. Saves us some money because we switch it back off at the end. Target our services, run the tests, and pull the results back into our integration server, as an example there with some failures. The good thing with doing this is our pipelines can then be blocked from release into production, and we find that then people jump on things because they want things out. So again, it highlights the need for security. The value we find with this is obviously early testing, faster feedback. So every week, we're developing new things. As part of that, we're writing new tests, we're running those tests, and we get feedback straight away. The thing with that is it also has a feedback loop. As we fix things, as we find them, people are applying that knowledge and not making the same mistakes as we go forward. But ultimately, it gives us confidence in our products, and it reduces the risk that when things get into production, we're not going to have some sort of incident happen. It doesn't take away from the fact that we also need to have penetration testers come in at some point. But rather than paying lots of money out for them to come back repeatedly because we've constantly got issues, we get to a point where we've got a good confidence, and the things that come back aren't big lists very often. But based on their expertise, they do find some things you don't think of, which is good and is why you need them. I'm going to pass over to David Brownhill, who's going to go through another example with Gauntlt and the way he's used that. So these use different tools: curl, nmap, SSLIs, SQL map, etc. And we'll just switch over for David to go through some of that.
Thank you, Scott. So I used to work with Craig at Skyscanner, and this is where we initially began getting into application security as part of the continuous delivery pipeline. So since then, I've mostly worked in government projects, DWP, NHS Direct, DVSA, and mostly working in non-functional service teams. So from that perspective, it means that when stories are coming into a sprint in Agile iteration, we're going to be assessing a user story from planning, what criteria is required from application security, session management, cookies, managing the user ID, and also performance as well. So those two major areas. Trying to push those into the pipeline alongside the usual unit integration and functional testing. So, for example, the digital service here at DVSA, I'm no longer DVSA, but we're split across these three areas: software development, architecture, technical support. So the software development, number of teams creating features, coming out of requirements come from product owners. And in the center here we have the architecture. And I was in this area here, performance and security. Information assurance, that's all about data protection, and that was managed separately. So we were trying to get these requirements into the functional features. Technical support, that's obviously a lot of security work around infrastructure as well, and this non-functional testing is around firewalls and network access. And people being having access to the correct folders and everything on the network. So, continuous delivery flow. We were looking to set up the artifact repository, which was coming out of our features, and then we were pushing it from left to right. This is the amount of testing, manual gates we were doing, and initially, obviously, in a kind of more naive environment, less mature, but perhaps a better word for it. Look at manual gates, so you'd be looking at, say, Craig was talking earlier about a lot of security testing we used to do manually using tools like WebSuite and Zap, SLYs. We're just doing that specifically within the feature team, so you've got acceptance criteria. And we'd actually just use those tools and manually verify that they're correct. So every 3 months when we'd have the external penetration testers come in, we would hope that they wouldn't have to spend so much time going through the whole broad range of security criteria. Yes, they obviously did have a full range, but we were trying to pick up some of the low-hanging fruit so they could sort of get through those quicker and maybe and obviously spend more time in the edge cases and helping us that way. And that's where we were trying to push the NFT work into the pipeline, because obviously doing manual tests through to the storage was time-consuming, because we were responsible for the performance and the security. So spending a lot of time with writing our JME scripts and our Zap scripts, push them in the pipeline such that we're left to right, and we've only got these 2 manual gates here before it goes out of production. So this is our journey for continuous integration. So as you can see at the start here, most people will always target the function tests, standard pyramid, looking from the bottom upwards. You'd be going from unit integration, component contract in UI, and then version 2.1, we were looking to get far more static analysis in, and this is where we first started doing our security testing. So SonarQube is a tool that sort of verifies the functional correctness of code coming out from the development teams, but you can also add rules for performance code and for secure code. Well, the secure code is actually what comes out of the box is minimal, let's say, but it gives you full functionality of adding your own rules and then hooking plugins from tools of your choice. So if you've got a Zap script, you can hook it from this point as well. So static analysis of your code and ensure that it's been written in a secure fashion. Next stage, coming down 2.2 from our continuous integration implementation plan, is where we're pushing in. So we've statically analysed our code that is securely written and performant. And then after we got these 2 working satisfactorily, we're looking to push in our non-functional tests. So from a non-functional test service, we were taking from our feature teams JMeter scripts and Z-attack proxy scripts. That's an application security tool. We would then sort of retrofit those into the pipeline so that they weren't just running solo, which obviously they were in feature teams, but they could be running as a suite overnight. So sometimes I need tweaking from a data perspective and set them on specific suites that can be run during the daytime, nice and fast, so good feedback, and then run the full suite overnight as well. So we had to accept an NFT environment in AWS, which we could spin up an accept for function We had two non-functional test environments for performance regression and application security, hence multi-branch pipelines. So checking out code for each of those three environments. SonarQube. Yeah, so these are the rules that we had added into our SonarQube in our static analysis part of the pipeline. So OWASP top 10, I think they've been published those annually, but they're sort of generally roughly the same. Single injections usually top 5 or so. And so these are the rules that we plugged into our SonarQube for analysing developer code. Direct object referencing, but single injection is a big one. Now we use Gauntlt. So Craig talked about BDD continuum security as a framework. It's a bit like Selenium when you're using SpecFlow, or there's sort of DSL test case language tools like Gauge and Concordian, which use Markdown. They're quite cool. Gauntlet's sort of similar in the sense that you define your test scenario with an arrange, an action, and an assert. So I've just pulled this one out from one of the projects we're working on. And just ensuring that all the cookies are set up properly when they're being managed on a user journey. And I mean, there's vulnerabilities which can be exploited if this is not set up properly. So we run this script as part of the continuous pipeline to ensure that all cookies are managed properly. Production code, obviously we're wanting devs to write code securely. So as part of the process of developing this, we'd have code reviews with the team's tech lead. So a feature team would have a tech lead or senior developer, and they'd be responsible for reviewing all the code that's written. So it has to be written in the style recommended by our engineering department. But we'd also have a checklist for code to be performant and secure, which we developed in-house and following industry standard guidelines. These rule sets we defined, and we're trying to automate them into our static analysis on a cube. And the attack vectors here is that having defined the rule set, we would then define the we could set up the attack vectors that were likely to be vulnerable to be exploited, and then we try and do those on sort of we'd have workshops where we'd have engineers trying to use those attack vectors against our sites, just as a sort of a tech lunch time exercise. Have I covered this? Yes, regression execution. So just like a functional regression, your in Selenium, you're looking at regression suites against new functionality, so the previous functionality hasn't been broken. And we'd also be doing that as part of our security. So if people have made changes to how sessions been managed, that if we haven't broken some other security criteria that have been defined in previous sprints. So application security regression suites are important. And we were talking about the attack vectors. We used to have a little tech lunchtime meet where we'd be sort of manually exercising stuff against our sort of accept and pre-production environments. And we could also, when having defined those, we'd also add those into our pipelines too, so that it would actually run some vectors against the release. I've covered this now. It's a non-functional requirement, separate environments for volume and vulnerability tests. And so we've got the devs producing general description, we've got the devs writing our Z-attack proxy active scans. So they'd be writing both these, feed them into the non-functional team, and we would integrate those into the test suites. And these attack scenarios, that would come out of planning. So just like you do with a test scenario, you get your acceptance criteria, and then you define the acceptance test and flesh out the requirements for that. We'd have attack scenarios identify it in planning, and then we'd flesh out how we'd define those as attack vectors and how we'd be able to defend against them. And that's it. I think questions.
Any questions? Yes?
Did you consider any alternatives to SonarQube?
I'll be one for you, David.
There seems to be a range of options.
Yes, there is. Personally, no. It was a decision that came out of we're talking about the structure of the engineering team, and it was a kind of, I mean, I don't know whether they'd, I'm not sure they had done a proof of concept on different options, but when I joined, SonarQube was de facto, and that's what we were working with. So I don't know why they chose that one. In your experience, have you used other options?
I'm in the process of evaluating multiple SaaS tools at the moment. SonarQube's going to be one of them. I'm just curious how different companies come to use different.
Yeah, I wasn't privy to how they came to that, I'm afraid.
Yeah, I guess when we worked together at Skyscanner, we did go through proof of concepts. We tried a few of these frameworks. We also tried various paid services. We tried a couple of, I can't remember the name of them off the top of my head, but we ended up going with Veracode as a security scanning option for static analysis. But we went through about 3 months of trials with different software.
Yeah, we went through a very laborious trial with checkmarks. I'm sorry if there's anybody from checkmarks in the room, but difficult company to deal with. At the very end of the story, 3 months in, we found it to be prohibitively expensive.
The order of the pros and cons, I think we used, we part of our proof of concept was with White Hat Security.
Yeah, we tried White Hat.
And they were quite good from the support level for mitigating flaws that were reported.
Yeah.
Can't remember why I didn't go with them. I think
Expense, I think. It always comes down to that.
One of the common gripes that we get from developers in our team is the length of time it takes for pipelines to run.
Yeah.
So currently we do a lot of dynamic code analysis, live production software testing using NetSparker. That's our primary tool. But it doesn't interfere with the release process in any way. It's software that's running doing tests.
Okay.
We tried implementing NetSparker into CD, but it slowed it down to the point of it being impossible to get software out. Because the scans took so long to run. Is that something that you've experienced with your setup?
It's something as a test engineer you get all the time, particularly like functional tests, for instance, with Selenium as well, take a long time to run. The way we get around that is those type of suites we run nightly. If there are failures, they still block the release if we want to release the next day until we get a green run through. But they're not part of the flow through to our pre-production environment. So we've got like a development environment, integration environment, pre-production, and then out to production. So that's how we do that.
But also, wasn't that why we switched to try and develop specific scenarios against frameworks like Gauntlt?
Yeah, so the company I'm at now, we use Arachne Scanner. We run at weekends because we're on weekly sprints. Finish the sprint, run a weekend scan, we release on a Monday. That again takes the weekend to run sometimes. You've got a large application, but the specific scenarios allow you to target a bit more. So you can, instead of running a scan that will spider out and find things and test the same things laboriously, you can tag those scenarios. So if you've only made changes in one area and you know that there's a risk of something, you can say by this tag run only these scenarios and get faster feedback as well. So more like smoke testing something.
So that is what we're talking about, the attack vectors. So we identify the attack vectors and we can target the scenarios and then run those. So we tag it on the attack vector and then just run those specific tests rather than doing the whole scan. Yeah. Using Arachne or NetSparker.
And depending on what integration server you're using, if you're doing stuff per commit or through a pipeline, you can commit with certain parameters to only initiate certain scans. So. Anyone else?
In terms of SQL injection testing, are you testing at the level of just ensuring the code is using something like prepared statements, or are there any tools you use which try random attacks against known fields, or do they predict fields? What level do you go into in terms
So from my point of view, we aren't using the framework for the SQL injection. We're using Arachne Scanner at the weekends, which goes through our application, and there's you can have a whole suite of different attacks that it does for that. It's not something I've looked at specifically. You mentioned on your slide about it, so maybe you've got a different answer.
Similar to what you're saying, SonarQube, we'd won a nightly one, so we set a rule set, and then some things that come out of the box are SQL injection and the direct object reference, and they just come in with a whole load of suites of tests. So similar to Arachne, we just run that overnight. Yeah. But we wouldn't define specific attack vectors for SQL injection because there's so much out there that just comes out of the box.
Yeah, it's probably worth mentioning as well that you still need manual testing to pick some of these things up. These tools aren't foolproof. They can have false positives and miss things. So
I'm mentioning false positives there. All our pipelines, which I didn't mention, functional regression pipelines, if that went red, we'd stop the release. Performance regression pipeline, if that went red, we stop the release. But on our security pipelines, we want to stop the release on that because of the number of false positives. So when those errors came up, we'd sort of eyeball those and see what's going on because. When it's going to continuous delivery, we just have the performance and the functional. The security one we'd run separately, which I think we did a Skyscanner too.
Yes. Anyone else?
Just out of curiosity, are you integrating any kind of Docker image-based security assessments as part of this?
So, not at the moment, but my company is looking at moving to using Docker for a lot of our software, particularly for our pipelines. So, it's probably something we will look at, but not at the moment, no. Thank you.